Swapping a refrigerator compressor relay seems simple, right? But one wrong move can burn out your compressor and cost you a fortune. In this video, I'll show you the most common mistakes people make when swapping relays and how to test them properly to avoid damaging your refrigerator. Let's get started. I have different types of relays with me, which are used on refrigerator compressor terminals. Have you ever tried exchanging them to see how they work? If not, let me show you in today's video. You can see that we have two compressors in front of us, which are refrigerator compressors. The compressor on the left is 1x5 horsepower, and the compressor on the right is 1x4 horsepower. The connection patterns for both of these are different. So take a look at this compressor. One pin is positioned at the top, while the other two are at the bottom. On the other hand, in this second compressor, one pin is at the bottom and the other two are at the top. So here we have a current relay, and this is a PTC relay. Inside it, there's an overload protector and a PTC relay. Besides that, we also have a few separate overload protectors with us. There are other types of overloads and relays as well, but I am showing you the ones that I currently have with me. So can we remove these relays from one pattern and use them in the other pattern? We'll discuss whether these relays can be exchanged and used with different compressors. So let's start by talking about the current relays. First, we have these downward current relays, and then we have the upward current relays. Can these be exchanged with each other? Let's begin by discussing this. So here's how it works. This current relay we have, if you look at it, the opening or mouth is at the top, and its coil is also positioned upwards. If you look at the holes, there's one hole at the bottom and two at the top. This relay fits easily into the Danfoss compressor terminals. But when we start the compressor, at the moment of starting, since the starting point doesn't attach properly and only the run and common points are connected, electricity flows there. This causes a bit of a heavy current flow, but it only lasts for a few seconds, meaning it happens for just a few milliseconds. As soon as the heavy current builds up, it flows through this coil. From the coil, it then passes through to the common and run points, continuing its path to complete the circuit. When the heavy current builds up here, you'll hear a sound coming from inside the relay. This is because the relay contains metal, which gets pulled upwards due to the magnetic field. As a result, the 2 points inside the relay come together, allowing the compressor to start. This causes the current flow to reduce. Once the current decreases, the relay moves back down, completing the cycle and allowing the system to function as intended. Now, this second type of relay is commonly used in compressors, and you can also use an overload protector with it, depending on what you have available. When we use this current relay, its principle is the same as what I explained earlier. However, what happens with this one is that its opening mouth is facing downwards, and when it faces downwards, the coil inside pulls upwards just like the previous one, working in the same manner. Now, if we were to reverse this relay and install it upside down in place of the other one, it would fit perfectly. However, the issue is that the points, the starting point and the running point, would always stay attached. When these points stay connected, our compressor will burn out. Similarly, if you look here, the run is on this side and the start is on this side. If we flip this relay upwards, its points will completely change. The run point will shift here and the start point will move to the other side. If we install it this way, we will face the same problem. The points at the bottom will stay attached continuously. This will cause the compressor to burn out. So, the bottom line is that installing these relays in reverse is very risky, and that's why we cannot use them this way. Now, let's talk about what a PTC sensor or PTC relay is. I'll show you practically how it looks and how it works. If you look closely, you can see a metal disc inside, and on the sides, there are 2 points attached. Let's see how it functions. So first of all, you need to know what this is made of. Let me explain that as well. You can see that it's a disc made of a special material. There is no polarity involved in this. You can attach it on any side, and it will function properly in the same way without any difference in its performance. It works in a consistent manner regardless of how it's connected. The PTC sensor is made of polycrystalline material. The main ingredients of polycrystalline material are barium carbonate and titanium oxide. In addition to these, tantalum, silica, and manganese are also included. The disc is prepared according to the specific requirements using these materials. So now let's talk about whether we can exchange a PTC sensor and a PTC relay with each other or not. As I mentioned earlier, the disc inside works on the same principle, whether you place it upside down or right side up. Now take a look here. I have a Danfoss PTC relay in my hand, and it has 1 point at the top and 2 points at the bottom. Now, can we use it with this Panasonic compressor terminal? Yes, absolutely, we can. So see what happens. When we reverse these points like this, the line, neutral, and common connections also get reversed. And in the same way when we install it here, so after installing it, you can see that the start point remains on the same side. The run point is also in its original position, and the common point has moved to the top. This means you can easily install it without any issues. If the Panasonic compressor also has a metal plate welded underneath, like the Danfoss compressor, then it will be difficult. Otherwise, for Danfoss compressors, you can cut this metal part and install the relay. However, Panasonic compressors are flat in this way, and you can use this relay with them. Now, if we look at this relay, it has 2 points. You can see that it's labeled M and S here, which means the motor is on the left side and the start is on the right side. So, if we flip this relay, the motor will be on the opposite side and the start point will also change. When we flip it, both the motor and start points will be reversed. However, we can directly install it inside this setup and use it. Additionally, we can use any overload protection with it at the bottom and it will work fine. Now, here you can see that I've installed the Danfoss relay in a different pattern, similar to the Panasonic one. I'll now supply electricity to it. When we give it power, you'll see the issue here, whether it works properly and how many amps it consumes. Once we power it on, it easily draws 5.35 amperes, and then quickly drops down to 1.26 amps. This means it took a great start, and now you can see it's running smoothly, drawing 1.25 amps, which is excellent. There's no issue. Now, as you can see, we've also installed the Danfoss system, and since it has an overload protection, I added that as well, along with the PTC sensor relay. Now I'm supplying power to it, and if we look at the start, it's drawing 1.33 amps at the moment and has started successfully with no issues. So if you don't have the exact relays available, you can change them, but you must be very careful with the electrical polarity. Ensure that the line is connected to the common point and the neutral is connected to the running point. This will keep your compressor safe and extend its lifespan. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.